just a basic psychology class.
Right.
'Cause I have 4 kids, and I always I want to know more about the dynamic between like kids and the middle child and that kind of stuff.
Right.
So I have a cluster. So I'm doing a university studies with a minor in business, but then I have to do 2 clusters. So one of my clusters is in entrepreneurship, and then the other one is in like family, like parenting and family emphasis.
Yeah.
So I can learn more about the dynamic of the kids and that kind of stuff. So they're like easier classes probably, but like helpful classes to know with the kids.
Yeah. Are you going to be taking that developmental through the lifespan psychology class? Or is that the one you're talking about?
So I think so. Yeah, it's like it's a summer class. It's like I think it's 2 or 3 units, but you have to take I think 3 classes. So I'm taking that. There's a psychology class. There's a parenting class. There's like 3 classes that I'm taking. So I'll take 1 in summer, and then I'll take 2 in the winter semester, and then I'm done. So,
awesome.
So this semester is 283, 383, and then this class, summer is just a little generic class that that psychology class, and then the fall semester, that's the one. Have you guys taken 321, 331, 361? Have you guys taken those classes?
I'm in 321 right now.
Okay. Have you taken 301? Because you have to take 301, 321, 341, 361, right? Those are the 4 classes you have to take.
I don't know. I might have taken that at a community college, and it was called something else. I don't know.
What's your major?
Accounting.
Okay, then yeah, you may not have to take it. Bryce, what's your major?
Computer science.
All right, yeah, you guys might not have to take it. Okay,
I don't know.
So for any, I guess I thought for any business related, you had to take 301, 321, 341, 361. So I'm taking all 4 of those classes in fall, which is going to be a lot to take, but it'll be my hardest semester. So I mean, they say you can do it in 1 semester, but we'll see. We'll see how that goes.
Yeah.
So.
That's what last semester was for me. It was a beast. Now I'm just taking 2 classes when I graduate. So.
Dang, that's nice.
Is this your last semester?
Hopefully, yeah.
Oh man, I don't like you anymore. Oh.
Open, sorry.
I don't like you in the nicest way possible. No,
yeah,
it'll just be nice.
I feel you.
It'll be nice to just get it over with. You know what I mean?
I don't like my friends that have already graduated. So.
Right.
I know what you mean.
Yeah. So it's cool. It'll be nice. I mean, I obviously want to get good grades, but I'm to the point now where it's like my GPA is over 3.0. I just want to get past them, So if there's like a 5-point assignment and I'm like struggling, really, is 5 points worth it? I don't really care, So we'll see how it goes. I guess I shouldn't say that because it's recording, but
it's been my goal. Like the last 2 semesters, or like 3 semesters even, is just do something at least.
I know.
It usually turns out, but I'm just like, I need to at least try to do something. I don't care if it's good or not. But it's turned out
you
right.
already have all your credits. Are you in your last classes to graduate then? I mean.
Yeah, so I just have 2 classes that are required for my major, and this is technically we take engineering statistics, but I got it approved to take business statistics instead.
Oh, nice.
Of engineering statistics, and so that's why I'm in this class as opposed, because it's online and there isn't an online engineering statistics, and so
I imagine it's fairly similar anyway, right?
Yeah.
They have like all sorts.
I think it's the same content, just different application.
Right.
Right.
Plus, I don't know.
Go ahead.
Go ahead. Oh, I was just gonna say that I've kind of would like at some point maybe to get an MBA, and so it kind of fits in better. I like the more business side of development and all of that stuff, and so that's why I'm like, I'll do business stats instead too.
Yeah, that works
I don't know if it's all that. I don't like you say. I don't really know if it's all that different or necessarily
I'm
helpful for
sure
me to
it's
take business
probably,
as opposed to
yeah.
engineering, but
So where are you
it'll
going to do
work.
your MBA at? Where are you going to do your MBA at?
I don't know. I don't even know if I'm going to do it. I'm just going to graduate now and then go work for a while and then see if it's worth it to get an MBA down the road. But if I do go on with school, that's probably what I would do is get an MBA.
Well, see, that was my struggle because, I'm 34. I got 4 kids. I've been working full time since I got home from my mission. And I was in a business major, and they had misquoted, like kind of not misguided me, but they had given me some information that wasn't 100% accurate on my graduation plan, and there were some classes that they didn't catch that now I needed to take. So it was going to extend me even another semester. And that was going at like full throttle, like 9, 12 units a semester, which is super, super intense for me. I mean, I'm doing like 25, 30 hours of homework a week as it is. And I'm, married, 4 kids, full-time job. Like, it's a lot, So 3 classes, 9 units I'm okay with, but 12 is pretty hard. In fact, actually, it's almost impossible. It's just really tough. And so I went to, like, my recruiter. I went to, like, 6 or 7 different people and said, hey, when you're looking at a potential hire, are you looking for a business management major or what, a university studies major with a minor in business? Would that make any difference to you? And all of them told me it doesn't make a difference. Get this, in fact, a more broad range degree would actually look better for a company like Paychex, like the one that I'm at, because they don't want you to be so narrowed down to one thing. And so with the business degree, I kind of felt like I was, like, the focus is entrepreneurship, right? And I have no desire to be my own boss. So it's like, really? Like, what's the degree for? You know what I mean? So that's why I changed it, and I'm saving myself a semester and some heartache, So it's good.
Nice, man.
Yeah.
That's good.
All right.
Sweet. Let's do this thing.
Yeah, let's get rocking and rolling on this.
Okay. You have a play to catch tonight, right?
I do, yeah. My kindergartner, he's got a big part, It's like 2 lines, but it's a pretty good little, neglected and elected. He's got some words in there that are really similar, so I'm like hoping that he doesn't get confused by it, So, I mean, he's 5, you know what I mean? So we'll see what happens.
That's
cool.
Fun.
All right, should we start this thing?
Yeah. So lesson 7, group meeting, right?
Yep. I put lesson 6 on accident, not a thing, but anyway, that's all right. Any questions with the prep stuff?
No.
I'm trying to remember. I did it this morning, and today's been a long day.
Yeah, it was.
Trying to remember what it was even about.
It was just review, except there was one concept that was new. It was like, if you, like, the probability of choosing a random sample or something, and it was, I don't know. It wasn't too tough.
It seemed like it was combining, like, the last 2.
Yeah, that's how I feel too.
Yeah, it seemed like it was just combining, like, the last 2 things together, 2 lessons.
Yeah.
But anyway, cool. Well, I guess I haven't led it in a while. I can go ahead and do that. So, you guys ready?
Yeah.
You guys ready to do this
quiz?
Okay. Yeah. I got mine all pulled up, so. Let's see. I need to zoom in a little bit, though, because I can't read this. Okay. Use the normal probability applet to find the combined area under the standard normal curve that is to the right of the z-score 1.358 and to the left of the z-score negative. Round your answer to that. If the answer is blank, then you would, okay. So we're supposed to use the applet.
Okay.
Let me go find the applet real quick. Dun, 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 dun.
This is that applet of normal probability applet with the The graph thing?
Yeah. Yes, I believe so. Where was that? Where's the link to it? I need to like bookmark that. There it is. Normal probability applet. I'm gonna bookmark it. Okay.
So we need the right and left of 1358, is that right?
Yeah, so we're supposed to put in, oh, where are we at here? There we go. Yeah, so we'll just put in as the z-score, negative 1.358, enter. Yeah, so you get 0.1745.
Yep, that's what I got.
Is that what you got? Sounds like what it wants, right?
Yeah, and
0.1745.
Uh-huh. So
but
175.
So 0.175, right?
yep,
Because we got
I
around
think
into the
so.
3 decimal place.
Yep,
yeah,
Yeah.
I believe so.
that's what I got too.
All right. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower but was raised after a tragic boating accident. The standard deviation of passenger weights is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. I wonder how they got that. The sample mean. Could you get off your boat and sit on this scale, please? The sample mean was determined by 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme, either above or below the mean, that was observed in this sample. Okay. So,
Let's see.
let me read this again. Note, as an extreme or more extreme means that we are not only interested in values that are lower than the ones we observed, but the values that are as far away from the mean as ours in the positive direction. So basically it just means we want both the negative and positive sides.
Yeah.
Okay. So I'm guessing we just want to use that whole z-score equation where we take the, because it says, yeah, so it says it gives us a sample mean, right?
Yeah, one was it 185? Yeah, right.
185
Yeah.
is the mean. The sample
Yeah.
the sample mean was determined to be 177.6 pounds.
6.
Okay. So in this case, are we doing let's see, for the z-score, because it's x minus the average, right, over the standard deviation. Is that z-score?
Yes.
Okay.
Over the standard deviation,
So
which
X
is.
minus
But here, since we're doing a sample
26.7,
mean,
right?
it's the standard deviation divided by the square root of the sample size.
Oh, in this one, right? Yeah. Yep. Okay.
So what value are we I'm kind of confused here because we have two means.
Yeah, that's what's throwing me off too.
Well, the mean weight of commercial boats, and then it says the sample mean.
You know what I'm thinking? I think the
So it
equation
was
would.
raised.
I think it'd be z equals 177.6 minus 185 over 26.7 over the square root of
48.
yeah, 40 sample 48 commercial. Yeah, I think that's what it'd be. Maybe.
Let's see. Find the probability that a random sample of passengers will have a weight that is extreme or more extreme than the ones observed in this sample. Yeah, okay. So you're saying do 185 minus 177 or 177 minus 185?
177 minus 185, I think. Um, I,
185. That's negative 7.4. Sorry, I'm talking out loud. 6.7.
Almost it's confusing because it's saying that it was previously it was lower. Are they saying that it was lower? It was at the 177.6 and then they raised it to the 185, or are those two separate numbers? It's weird.
yeah.
Let me see here.
By doing that equation, I got negative 1.920.
See, I'm wondering if we should have 185 minus 177.6, because then we're basically saying, is the number that the U.S. Coast Guard
Assumes that's, yeah.
what they assume, does it make sense based on what was actually found as the sample mean
Right.
in the pounds? So we're basically using 185 as the X value. That would kind of make sense.
Well, yeah, because it almost, the question is right. The question is whether that number that they're assuming is right or not.
I think so. Let me see if I do that. Then we get that divided by 26. Oh, whoops. 26.7. So I get, as a z-score, I get 1.920.
Yeah, but negative, right? Oh, I'm sorry. You did it.
No,
You did
yeah,
185.
Yeah,
Okay.
so the only
Yeah.
difference is one's negative and one's positive. Doesn't matter. Okay, we're good.
Gotcha.
Yeah,
Okay.
if we use those two values, then we're fine, because the only difference is one's going to be negative and one's going to be positive, and that doesn't
Yeah.
matter because we're looking at both sides anyway. So
Okay, that works then. So we just plug that into the applet, right?
yep. Then we get an area of 0.0549. That's what I got.
0.549. Yep. And then to 3 spots, 0.55.
55. Yep.
0.055.
0.055.
Oh, 0.055. Okay.
Yeah.
Okay, cool.
All right, I think that makes sense.
Yeah.
Good with that.
It's nice
All
that
right.
either way it came out to the same, so that's
Yeah,
good.
it's like, oh wait, that does make sense because we're just subtracting the numbers in different orders. So it's just gonna be negative. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? The distribution of the individual observations, the distribution of the sample means. This cannot be determined from the information given. Should be the distribution of the sample means, right? Maybe not.
Yeah, I think you're right. I think so. Because how many? If there's 9, those could be spread out, but their averages are going to be closer, right?
Uh-huh.
That means.
Well, and their averages will form a normal distribution, which
Right.
is going to have an area of 1.
Yeah.
Just thinking of a normal curve, then that
Yeah,
probably.
I like that.
Okay.
Well, maybe, but I mean, I guess you could get the same. I don't know, because if you do it of the individual observations, you could get 9 for all of your observations. Well, but then I guess that'd be the same. So yeah, I guess it would. I mean, it's always either going to be the same or less of the sample means, because your sample means are never going to be more spread out than the data that you had.
True. So I think that's the answer.
Okay, cool. I'm happy with that. Feels like it's never this cannot be determined from the information given, but maybe not.
I think
I
we've had
know, at least
one.
not.
Maybe we had. Yeah, I think we did have one actually.
Yeah, and that's a.
All right, which of the following results imply the spread in X decreases as the sample size increases? The law of large numbers.
Yep. Mm-hmm.
Go with that one.
It's not the central limit theorem.
I like how they have 68, 95, 99 for all of them. You know, like they always have that one thrown in there.
Yeah,
As a
it's got to
wrong
be
answer.
that one. I think that's got to be that one.
Yeah.
Sweet. Okay, number 7. Sources on the quantitative portion of the GRE are approximately normally distributed with the mean of 150.8 and a standard deviation of 8.8. Use the information to answer questions 7 through 10. Diane earned a score of 160 on the quantitative portion of the GRE. What is the z-score corresponding to Diane's score?
Okay. So we do 160 minus 150.8
150, yeah.
over what? 8.8?
9.2 over 3.8.
Yeah,
1.0.
because we don't know the sample size here, so.
Yeah. So just the standard deviation.
Uh-huh. Since we're already assuming that it's normally distributed and we're not doing that. Okay.
9.2 over 8.8.
Yeah.
Oh,
Then that comes out to 1.045.
My fingers are not pressing the right buttons today.
So 1.05. I guess
Well,
it'd have to be to the 3 places, right?
yeah, so 1.045, I think. Like 3 places after the period, right?
Right.
Yes, 1.045. Yep.
Yeah.
That's what I got.
Are we rounding that out to the?
Well, because after the
Yeah.
5, it's another 4. So then that would just round down.
Okay.
If that makes sense.
Oh, okay. Yeah, right. 1.045. Okay.
Sweet. All right.
Yeah, because we're not rounding to the 2 decimal place. You're right. Sorry.
Yeah.
And then for this one,
What is
for
the probability? Oh, sorry.
Oh no, I was just gonna say I think for the next we just plug it into the applet. I think.
Oh, yeah. So what is the probability that a randomly selected student will score above 160 on the quantitative portion? Okay, yeah. So we put in 1 point. Oops, I'm in the wrong box. 1.045. And then if it's above, so we're doing the middle section and the right section. No, just the right section, because it's 1, not negative.
Right.
Gotcha. Then I got 0.148.
Yep.
All right, number 9.
0.148. Sorry.
Yeah. Yep. A random sample of 5 students was selected to take the GRE. Their scores are those ones. What is the z-score corresponding to the sample mean of those students' scores? So, if those are the scores that we got, we would find the mean of them, and then we'd find the z-score by dividing it. Let's see, do we have to find the deviation and everything of that? Probably. I feel like I need a piece of paper.
The mean between that's like 155, 145, I think.
What I'm thinking is
155, I think, is the mean.
yeah. Could we just add those up, divide it by 5, and then find the z-score of that, or does it need to be something more complicated?
Yeah. No, that's right. So we need to find the mean of them, right? And then we need to find the standard deviation as well so we can find the z-score.
Oh, that's
So
right.
160 plus 175 plus 163 plus 149 plus
Oh, hey, this will work.
153 equals divided by 5.
I got
So
160.
yeah, 160 is the mean.
Yeah, that's good.
Yeah.
All right. Oops.
You know what? I'm thinking
Right.
the standard deviation is just the same, right? Isn't it? Or were we never given that in any of them? Yeah, it's 8.8,
Yeah, the
right?
standard deviation was 8 point. Yeah, it was 8.8.
Yeah, so we don't need to find that. So we just plug in 160 minus whatever the average was, 150.8 over
Oh, okay.
8.8.
Okay. So we don't need to find the standard deviation, you think?
No, thankfully, because that's more work.
Yeah. So you got 160 as the mean. Wait, now I'm confused again. Okay, so we're going to take 160 and subtract that from 150. Is that right?
I think you subtract. I think it's 160 minus 150.8, right? Or is it the other
Yep.
way?
No,
Oh,
no,
okay.
that's right.
Okay, cool.
And then we'll divide that by 5 divided by, oh, sorry, no. We'll divide
Just
that by 8.8 divided by 5, the square root of 5, right?
Oh, I didn't do that. Maybe that is right. Yeah, I didn't think of that. Wait, when is that used? It's I think maybe you are right. I think maybe you are. Yeah.
So you take the mean divided by the approximate average, I guess, right? The mean of the distribution mean, and then you
Uh-huh.
divide that by the standard deviation by the square root of 5, which was the number of students, right? Which was the student were selected.
Yes.
Okay.
Yeah, I think that's right. So we'll just
Because
take the
we're
mean of
getting
that
we're getting the
set.
5 by the 5 students.
Yeah.
Okay.
So let's see. I got 2.338.
One sec. Yep, same here.
If that was the right process.
Yeah. I mean, that sounds good to me. I think we did it right.
Seems
That
reasonable.
makes sense on that. Yeah, it makes sense, yeah.
So, okay, cool. What is the probability that the 5 randomly selected students will have a mean score that is greater than the mean achieved by the students in the previous? So we just plug that z-score in and then see what the value is above that.
Wait, selected students. I think so.
I think that's what we do.
That would
Yeah,
make
so we
sense.
just take that z-score. Say, yeah.
So
Let me kind of check here. So
my one concern about this is I feel like in the homework or whatever, like in those situations, you have to do the standard deviation divided by the square root of, in this case, it'd be 5. But we already did that for the previous one, so maybe we don't have to do that again. But
on number 9.
yes, here I'm I'm looking at the wrong thing right now. Yeah. Well, no, for number 10, I'm saying. I don't know. I'm just trying to figure it out right now.
Well, I think for number 10, we just take that z-score we found in number 9 and then figure out what the area is above it.
That makes sense, but the part that's throwing me off is it says, what is the probability that 5 randomly selected? Now, the way we're doing it by plugging it in, I think
We've
that's
already
just
selected those.
for one, or just anyone to have it greater than that number, right? It's not specifically for 5, if that makes sense.
Sure.
But maybe that is how you do.
But I think that does make sense because if you think of doing it as a sample mean, we found that z-score, because that's the z-score of the mean of the set of 5, right?
Set of 5.
And so if we're saying if we go take another set of 5, we're still only getting one score because we're getting the sample mean out of those 5.
Okay.
We're saying what is the probability of that sample mean? Yeah, of that sample mean of those 5 students being inside the area greater than. Does that make any sense?
Yeah, I see what you're saying. Okay.
So we're basically treating the 5 students as one student for both cases because we're using sample means.
Or like distribution groups, right? Like you're saying, okay, you got all these. Let's say you got 100 kids. What's the probability that these 5 kids, if you take 5 other kids, that they're going to be similar? Which you've already kind of pulled that whole group, right? So it should be similar. Makes sense.
Yeah.
Right?
Yeah, it depends on what you say similar means, but yeah.
Well,
I think so.
Right.
I think it's the same idea.
Not similar, but yeah.
Yeah, I think I feel you. Yeah.
I plugged it in the applet and I got 0.0097. So rounding that, is it 0.010?
So yeah, that's what I put. I think that's what it is. I don't know if that's right. You guys can tell me it's wrong.
0.010, right?
Yeah.
0.010. Yeah.
Yeah.
Cool.
Yeah, that would make sense.
I don't know. That kind of makes sense to me because since we're using a z-score that was based off of the sample mean of 5 students, that's why they're asking for 5. So if they had asked for 1, that'd actually make it more complicated than asking for 5 randomly selected students.
Right.
Yeah. Okay, cool. Number 11. Suppose that the mean GPA of BYU Idaho students is 3.5 and the standard deviation is 0.7. It is well known that this distribution is left skewed. Good. A random sample of n equals 81 students will be drawn. Use this information to answer problems 11 through 15. What is the shape of the sampling distribution of the random variable x, which represents the sample mean of 81? Is that x bar? Yeah, it is. Okay.
Yeah.
Mean of the 81 students who are selected. So it should be approximately normal, correct?
Yeah. Mm-hmm.
Since the sample size is large.
Yeah.
Sweet. What is the mean of the distribution of the sample means, sampling distribution for all possible samples of size 81? This can be drawn from that can be drawn from the parent population.
So it's just the same, right? Of 3.5.
Yep, I believe so.
Does it say anything about rounding to? Oh, it just says round answer to 1 decimal. Okay, 3.5.
Right. 3.5
Oh.
would make sense.
Sweet, that would make sense for why they told us to do that. We use our test-taking skills.
Yeah.
What is the standard deviation of the sampling distribution of the random variable x bar, the mean of 81 students who are selected? Wait, what is the standard deviation? Oh. Okay, so this is, no, it's 0.7 divided by the square root of 81.
Oh, okay. So 0.7 divided by 9.
Yeah, because the mean is the same, but then, because if you think of going back to what we talked about last time, the whole idea of a sampling distribution is that we want to take the same mean that was in the old set and basically shift it over. Well, not shift it over. We leave it at the same spot, but then we reshape the curve by taking averages, and so the mean's always going to be the same. But then by reshaping the curve, we have to divide it by the square root of all of the samples.
Okay.
I don't know if that made any sense, but
It works.
we basically want the curve centered at the same spot.
So
I
0.7 divided by 9 is 0.078.
Yep, that's what I got.
Yep.
Okay.
0.078. Three decimal places. All right, 14. What is the probability that the mean GPA for anyone randomly selected BYIDO students will be less than 3.3?
So this is the type where you it's 3.3 minus 3.5 over 0.7 divided by the square root of 81.
Yes.
Right?
Yes. So 3.3 minus 3.5 divided by 0.7 divided by the square root of 81, which we already know what that is at 0.078.
Oh yeah, right.
So do this, 3.3 minus 3.5. All right, I got, as the z-score, I got negative 2.571.
I got negative 2.564. Hmm.
I wonder if it's because I put in the actual 0.7 divided by square root of 81.
Oh, okay.
If I change that.
Yeah, okay. Maybe we should go with yours because I used the rounded 0.078, so yours probably
Yeah.
accurate.
I hope that they're assuming that we're going to do it accurately.
Yeah.
So what's your answer?
What's going on in there?
Yeah, my wife's using a blender right now. Sorry.
Oh, that's what it is. Sounded like a motorcycle revving up. Or something.
You're like, why is there a motorcycle in your house?
I was like, where are you?
No, it's just a loud blender.
That's funny. So yeah, I got negative 2.571.
Negative 2.571. Okay, got it.
Yes. Yep.
Wait. It's asking for the probability, so we need to plug that in, huh?
Yeah, and find the area less than that z-score.
Okay. Negative 2.571, and it's 0.005.
Yep, that's what I got. And then 15 is basically saying the opposite. What is the probability that the selected BIIDO students will be greater than 3.3? And that's 0.995. That's what I got.
Yeah, that's what I got too.
Since it's just one subtracted.
So 14 is negative 2.571 or
Well,
0.005?
Because that's the z-score, the 2 one, and then you plug that in and it's the 0.005 one.
Okay.
All right. Are we ready to turn it in?
I believe so. I'm ready. Oh, I need to check the first boxes. Okay, now I'm ready.
Okay. 1, 2, 3. And yes. And 100.
Yay, 100.
Nice.
Well done, team.
Mine
I guess
still
our
says
assumptions
committee.
were right.
Yep.
No 100 for you.
Yeah. You got an F. You got committee.
A 0. Why?
Yeah, I don't know what's going on.
Huh.
Wait, you
Well,
really didn't get 100?
No, it hasn't told me yet.
Oh. Okay.
It's
I
saying
think your internet's not.
I don't know what it's saying.
Maybe.
So, no, mine gave me like a little thing where it says, "Oh, log in," And so,
No.
yeah, it's
It'll take a minute. Yeah. Well,
being difficult. It's not a big deal.
alarm's going off. Cool. All right. Well, I guess let me know
Thanks,
when
guys.
yours is yours done, or are you just gonna wait for it?
Yeah, I can wait for it. It's not a big deal.
Alright. Cool.
I'll log
Sweet.
in to another page.
So next Tuesday at 5 your time, 6 our time. Is
Yeah,
that right?
that's fine.
Okay, cool.
Sweet.
See you then.
Thanks,
All
guys.
right.
See ya.
See you
All
guys.
right.
Bye.
Have a good one.